Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a cone which is having base diameter equal to 50 millimeter and axis height is equal to 65 millimeter. Now we are required to obtain the orthographic projections of this cone when this cone is resting onto the ground on its base, and after the construction of the front view and the top view projections of this cone, now we are required to evaluate the shortest path by which a point P starting from a point on the circumference of the base and moving around the cone will return to the same point. That is, this is going to be our starting point on the leftmost corner of the base over here. So a point P, it has to cover the shortest distance in such a way that it is going to move around this particular cone in a particular orientation, and it should be returning back to the same point which is going to lie onto the base, such that the distance covered by this point P, in order to move along by one revolution, it should be working out to be the minimum possible distance or the shortest possible path traversed by this particular point. So there can be another statement for this question, that is, there is an insect or a bee which is going to start from a point of the base on the left hand side. Now this bee moves around the surface of the cone and finally comes back to the same starting point over here. That is, it will cover one revolution of this cone over here, and again it will be coming back to the same point. So there can be two paths over there. One path can be alongside the circumference. We can see this path will be equal to 2 pi r, but it is going to be a long path as we can see over here. So now we have to evaluate the shortest possible path so that this ant or a bee, it should be moving around the surface of this cone and it should be covering this cone in one revolution, so that the starting point and the end point of this particular insect or the bee should be the same. So we are required to evaluate the length of the shortest path that the bee should be taking in covering the distance along the surface of the cone over here. So here the base of the cone has been provided to us as 50 millimeter diameter and the axis height has been provided to us as 65 millimeter long. So now we can check over here, if this is the front view projection of the cone, this is the top view projection of the cone. Now we have been provided with the information that a B or a point P, it should be starting from the leftmost base point of this particular cone over here. So the first path we have discussed, it could be along the circumference. So if this particular B or the point B will be moving alongside the circumference path, so we will see that a very large distance has to be covered by this particular point P over here. The second path could have been like this. So again the distance would have reduced, but still it is a larger distance. The third path we could have covered over here could have been like this over here, but again a larger distance is required. And another path which the insect or the point P could have followed is this one, but again we can see this is a larger path over here because of the curve involved over here. So we know that as we obtain the development of the lateral surface of this cone, now we can check that the starting point is also point A, end point is also point A over here. Let us assume this point happens to be point A. So the shortest distance between 2 points is always a straight line. So we can see that this point P or a B, which is going to move along the circumference of this particular cone and return back to the same point, traversing the minimum distance, then this minimum distance should be along the straight line path which is obtained after you obtain the development of the lateral surface of the cone over here. So that the starting point and the end point of this development will be the same point over here. So now what we are going to do, first of all, we are going to obtain the orthographic top view and the front view projections of this cone. And then we are going to obtain the development of the lateral surface of the cone. So we know that the development of lateral surface of the cone is nothing but it is the sector of an arc over here. So once we obtain sector of an arc as a development, then the starting point and the end point of this lateral surface development of the cone we are going to join with the help of a straight line. And then whatever points of intersection will be obtained onto this cutting edge or a straight line or a string which is going to join point A of the starting point of the developed surface and point A of the last point of the development of the lateral surface over here. So now intersection of this string with all the generators, it can be 8 generators or it can be 12 generators over here. So with respect to 8 or 12 generators, whatever points of intersections we will be able to obtain, so those points of intersection we are going to bring back to the elevation view and the plan view, and then we will be able to evaluate the distance traversed by this point P or the B into the front view projections and the distance covered by this point P into the top view projections over here. So let us evaluate to begin with the top view projections of this cone as the observer is going to look at this cone from the top position over here. So as the observer is going to look at this cone from this top position, we are going to observe the circular projections of the base of the cone projected onto the horizontal plane over here. So we know that the diameter of the cone happens to be 50 millimeter. So onto the horizontal plane, a circular projection having diameter equal to 50 millimeter we have been able to obtain. And now we have divided the circular projection obtained onto the horizontal plane into 12 equal parts so that the included angle for each one of these 12 sectors will be equal to 30 degree each. So the 12 points we have projected into the top view projections over here. And we have also marked the access points O and O1 into the top view projections over here. So point O, it is the apex point of the cone, while point O1, it represents the access point corresponding to the base of the cone. So now since we have divided the circle into 12 equal parts, so there will be 12 slant generators which will be available. So now we have joined all the 12 slant generators into the top view projections over here. Now having obtained the top view projections of this cone, now all these 14 points we are going to project into the front view projections over here. 12 points corresponding to the base, 2 points corresponding to the axis over here. So the 12 points of the base we have obtained onto the XY reference line, and we have marked the axis height as 65 millimeter over here. The moment we mark the axis height, the point of the apex, that is point O dash, has been appropriately located over here. So once again, now we have obtained 12 points corresponding to the base in the front view projections. Apex point has also been located. Now this apex point and the base points we can connect over here. So the moment we connect 12 points of the base with this apex point, so now 12 slant generators of this particular cone, they have been evaluated into the front view projections over here. Now we can see that the two slant edges O1 and O7, they happen to be parallel to the vertical plane. So in the front view projections, the slant lengths over here O dash 1 dash and O dash 7 dash, they will be appearing as true lengths in the front view projections over here. So we can check that into the front view projections corresponding to this cone, only two of the slant generators, O dash 1 dash and O dash 7 dash, they are appearing as true lengths over here, whereas the remaining 10 generators over here, which are marked with orange color lines, so these 10 generators, they are appearing as apparent lengths into the front view projections over here. So now, in order to obtain the development of the lateral surface of the cone, we need to obtain this edge length corresponding to sector of an arc equal to the true length of the slant generator corresponding to this cone over here. So this edge length corresponding to the sector of the arc, it should be equal to O dash 1 dash, or it should be equal to O dash 7 dash over here. Now the length of this slant edge, O dash 1 dash, it is true length. This we have obtained. So now equal to this radius O dash 1 dash. Now we have drawn a circular arc over here, and onto this particular arc we are going to mark 12 points over here. So since this included sector angle for all of these sectors, it happens to be 30 degree each. So therefore, whatever sector length we have been able to obtain between the points 1 and 2, so the same arc length will be available for the remaining 11 sectors over here as well. So now with 1 dash point as the needle point, now we are going to mark 12 arcs over here, so that we obtain the points 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and again 1. So now we can check 12 sectors we have been able to obtain over here, corresponding to 12 segments of this particular circular projection. So now, having marked all these 12 points alongside this particular arc over here, now the apex point O is already available with us. So now what we can do? We can join all the slant generators starting from point O with all the 12 points of the base over here. So this way, the development of the uncut cone has been obtained over here. Now we see that we are required to obtain the shortest distance that a point P or a B, it should be moving along the circumference of this particular cone, and it should be covering this entire cone in one revolution, and it should be coming back at the same point 1 dash over here, and the distance traveled by this point P or the insect should be the minimum possible distance over here. So if we join point 1 and point 1, starting point and end point, using a straight line, because we know that shortest distance is the distance between 2 points, that is the definition of a line. So if we draw a line joining point 1 of the starting point and point 1 of the end point of this development, so we will obtain that the distance covered by the point P would be the shortest distance. Even if the point P is going to follow this path, it is going to follow this path, so the distances covered in the different paths, they will be greater than the shortest distance, which is a straight line distance between these 2 points, 1 at the start of the development and point 1 at the end of the development over here. So now what we are required to do, we will assume that there is a string which is going to join point 1 at the end of the development with point 1 at the start of the development of the lateral surface of the cone over here. So now the points of intersection of this string with the slant generators of this cone we are going to evaluate, and the points of intersection you can see we have marked as O1 has been cut at the point A, OB has been cut at the point B. OC slant generator has been cut at point C. Similarly, O4 slant generator has been cut at the point D. O5 slant generator has been cut at point E. O6 slant generator has been cut at point F. Similarly, point G lies on O7, point H lies on O8, point I lies on O9, point J lies on O10, point K lies on O11, and point L, it happens to lie onto the slant generator O12. So now we have identified if the point P is going to follow this path alongside the circumference of the cone, the distance covered from the starting point and the end point will be the minimum path over here. So now these points of intersection of this string with the different slant generators of this cone, we are going to project into the front view projections and into the top view projections. And once we join all of these points of intersections into the front view projections, we are going to obtain the path of movement of this point P into the front view and the path of movement of this point P in the top view projections over here. So let us start with point number 1 over here. So we can see point number 1, that is it is going to correspond to O-1'. So O-1' has been cut by this string at point A over here. So point A lies here, point A lies here, point A lying onto the circumference of this arc over here. So now if we project this point A back onto O-1', so we find that A' point and 1' points, they have coincided with each other. That is, at this extreme point 1', which is coinciding with A', our string or the cutting plane is going to intersect with O'1' at the point A' over here. Now we can check the next two generators which are overlapping with each other. They happen to be O'2' and O'12' over here. So this is one set of generators which are overlapping with each other. Now we observe that the slant generator in the development O2 generator has been intersected at the point B, and O12 generator has been intersected by the string at the point L. And we observe that the distances of the point L from point O and distance of the point B from point O, it happens to be the same. So what we are going to do? We are going to mark an arc from the point O. So this point O will be our center. So OL, it is equal to OB. Why this is equal? Because the points of intersection of the cutting plane with the coincidence of the slant generators O', 2' and O'12' will be the same. So what we are going to do, since OL, it is equal to OB. So once we draw an arc through point O passing through these 2 points, and then we bring this arc up to the true length of the generator O'1' over here. So the true length of this cutting point of intersection will be obtained onto the true length. So this point will be B1' and L1' over here. So through these 2 points B1' and L1', once we draw the horizontal projector line from this true length intersection point up to the apparent length of the slant edge projectors O', 2' and O'12' over here. So now you can check, we have drawn a horizontal projector line onto the apparent length of these slant generators over here. So onto O', 2' and onto O'12'. So the 2 points of intersection, they will be obtained as B' point will be located onto O', 2', L' point will be located onto O'12' over here. So the 2 points in the front view, they have been obtained over here. Now the next 2 points which are available with us, they will be lying onto the slant generators again, which are coinciding with each other into the front view projection. They happen to be O', 3', O', 11'. Now into the developed surface area, the 2 points of intersection which are obtained on O3 and O11, they happen to be points C and K over here. And once again, distance of point K from point O and distance of point C from point O happens to be the same. So now with O as center, we'll draw another arc which will be passing through the points K and C such that this arc will be extended up to the true length, that is O-1' slant generator over here. So the 2 points C1' and K1', they have been obtained over here. So from the true length point C1', K1', now again a horizontal projector line will be drawn which is going to intersect the apparent lengths corresponding to the slant generators O-3' and O-11' over here. So these 2 points of intersection will be obtained as C' point onto the slant generator O-3', K' point onto the slant generator O-11' over here. Now the next 2 set of slant generators whose apparent length is visible to us in the front view projections, and both of them, they are coinciding with each other. It is O-4' and O-10' over here. So we know that both of these slant generators, they are coinciding with each other as apparent lengths in the front view projections. Now onto the developed surface, point D lies on O4 and point J happens to lie on O10 over here, and we know that the distance of OJ and the distance of OD happens to be the same. So through the points J and D, again another arc we have drawn through the point O over here, and we have extended this arc up to the true length of the generator O-1', so that we are able to obtain true length points D1' and J1' onto the true length over here. At this point, D1' and J1' will be located here onto O-1' projector. Now from this true length, again we are going to draw a horizontal projector line onto the apparent lengths O-4' and O-10', so that 2 points of intersections D' and J' will be located onto O-4' and O-10' respectively over here. Now next couple of slant projectors into the front view projections, they happen to be O-5' and O-9'. Now let us evaluate their points of intersection with this string onto the developed surface view. Onto O5, point E is lying. Onto O9, point I is lying over here. So we know that the distance of point I from point O and the distance of point E from point O, again it is the same. So again with O as the center point and I and E as our radius points, again another arc has been drawn, and this arc has been extended up to the true length, that is O-1' over here, so that we obtain the points O-E' and O-I' over here at the true length over here. Now from this true length point O-E' and O-I', now a horizontal projector will be drawn onto the apparent length of the slant generators O-5' and O-9', so that the 2 points of intersections E' and I' can be obtained over here. Next couple of slant generators overlapping with each other in the front view elevation, they happen to be O-6' and O-8' over here. So now into the developed surface, we have got point F lying onto O6 and point H lying onto O8 slant generator, and the distance of OH and OF, it is again the same. So now with O as the center point, OH and OF as the radius, again another arc has been drawn and it has been extended up to the true length O-1' over here, so that we obtain the points F1' and H1' over here. onto the true length. So from these 2 points F1 dash and H1 dash, now again a horizontal projector line will be drawn to intersect with the apparent length of the slant generators O dash, 6 dash and O dash, 8 dash over here. So onto O dash, 6 dash, point F dash has been located over here, and onto O dash, 8 dash, point H dash has been located over here. Now the last slant generator is O dash, 7 dash over here. So now onto O dash, 7 dash into the development surface view, the point of intersection happens to be G. So through point G, once again we have drawn a curve, extended it up to the true length. From one true length O dash, 1 dash, we have drawn horizontal projector up to the another true length O dash, 7 dash over here. So this point of intersection of this horizontal projector will be G dash. So point obtained here also will be G dash. Point here obtained here will also be G dash. Why? Because O dash, 1 dash is also true length and O dash, 7 dash is also the true length. So point G dash is obtained over here. Point G dash is obtained over here. So this way we have obtained all the 12 points of intersection in the front view projections corresponding to the path traversed by this point P alongside the circumference. So please check how this path will be traversed. Now the point P is going to move from this point, touch all these points over here. It will be reaching this point G dash, and again from point G dash, again the same path, same reverse path, it will be traversed back till the point P is going to reach this point 1 dash over here. So this is the front view projection of the path followed by the point while completing one revolution alongside the surface of the cone will be there, such that the distance covered by the point P should be minimum over here. So the 12 points of intersection we have been able to obtain in the front view projections. Now let us obtain all of these 12 points of intersection with the slant generators into the top view projections over here. So now let us obtain the intersection of all of these 12 points of intersection obtained into the top view projections over here. Now we know that point 1 dash and A dash, they have been coinciding with each other because the B is going to start from this extreme point 1 dash over here. So as we bring projector from A dash into the top view projections, we'll find that point 1 and point A, both of them, they will be coinciding with each other. Next set of points we have available with us, that is B dash onto O dash 2 dash, L dash onto O dash 12 dash over here. So if we bring a vertical projector from B dash and L dash into the top view projections, so the intersection of this vertical projector through B dash and L dash with O2 will provide us with the location of the point B, and the intersection of this vertical projector through L dash with O12 will provide us with the location of the point L in the top view projections over here. So 2 points B and L, they have been obtained onto slant generators O2 and O12 respectively. Next two couple of points which are available with us, they are C dash and K dash obtained on O dash 3 dash and O dash 11 dash over here. So once again, if we draw a vertical projector through C dash and K dash into the top view projections, so the intersection of this vertical projector with O3 will provide us with the location of the point C. The intersection of this vertical projector with O11 in the top view over here, it will provide us with the location of the point K into the top view projections over here. Next 2 points. So now the 2 points of intersection, they are available as D dash and J dash. Now if we bring a projector line from D dash and J dash into the top view projections, we find that we are unable to obtain the points of intersections D and J onto the O4 and O10 slant projectors over here. Why? Because we can check these two slant generators, they are lying perpendicular to the observer over here. So observer will not be able to visualize the intersection points of D and J onto O4 and O10. Why? Because observer is going to look at O4 and O10 in the perpendicular direction. So what the observer has to do in order to obtain points D and J over here, observer has to look at this particular solid from 90 degree, that is from the side view. So now there is a definite relationship between height and the radius. So corresponding to this point of intersections D dash and J dash, we know this height. So the cutting plane has cut this particular slant generator at this height. So corresponding to this height, we know the radius. So now what we have to do, corresponding to this radius, we have to plot radius in the top view projection over here. So now we can check from points D dash and J dash. We have drawn a horizontal projector line onto O dash 1 dash over here, projection line. So from O dash 1 dash, once we bring this projector line downwards over here, this is the projector line. So now this radius through D dash and J dash height points, so it has been transferred into the top view projections. Now we will be transferring this radius back onto slant generator O4 and slant generator O10 over here. So now we are going to keep our needle point at point O. Open compass is equal to this radius, and then mark this radius onto the slant generator O4 so that the point D can be evaluated. Mark this radius onto the slant generator O10 so that point J can be evaluated over here. So this way, by looking at the solid from the side view, obtaining the radius corresponding to this height, and this radius has been transferred into the top view projections over here. So we have been able to locate 2 points of intersection D and J in the top view projections over here. Now the next 2 points available with us, they happen to be E dash and I dash lying onto the apparent length slant generators O dash 5 dash and O dash 9 dash over here. So if we draw a vertical projector through E dash and I dash into the top view projections, so the intersection of this vertical generator with slant generators O5 and O9 in the top view projections will provide us with the location of the points E and I in the top view projections over here. Then the next couple of points of intersection available with us in the front view projections, they are F dash and H dash obtained onto the slant generators O dash 6 dash and O dash 8 dash respectively. So now once we draw vertical projectors through the point F dash and H dash into the top view projection, so this is the vertical projector. Wherever this vertical projector intersects with O6, we obtain the point F over here. Wherever this vertical projector intersects with O8, we obtain the point H over here. And finally the last point is G dash. So point G dash happens to lie onto the true length O dash 7 dash. So through this point G dash, once we draw a vertical projector, let us evaluate the intersection of this vertical generator with the slant generator O7. So wherever this vertical generator, it is going to intersect with O7, point G in the top view projections has been obtained. So now all the 12 points of intersection of this cutting plane or the string with the different slant generators of the cone, it has been obtained in the top view projections over here. So now once we join all of these 12 points of intersection in the plan projection view, so we will be able to obtain the top view projections of the distance traversed by this point P while covering the surface of the cone in one revolution and reaching the same point which is lying onto the base as the end point of its journey over here. So in the front view, the journey of the point P will be like this. The point P will be starting from this point, moving along the surface of the cone up to this point, and again moving back in the same fashion till it reaches this particular point A over here, right? Similarly, in the top view projections, we can see now the end or the point P, it is going to move along the circumference of the cone in one revolution so that it is going to pass through the surface of the cone and it should be reaching at the same point of the base after one revolution, so that the distance covered by this point P should be the minimum possible distance over here. So it should be the shortest distance covered by the point P. So this is all for today. So today we have discussed that if a point has to move alongside the surface of any given cone in such a way that the starting point and the end point of the journey of the point A has to be the same after completing one revolution. So the distance covered by the point P should be the shortest possible distance over here. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures as well. So thank you very much. Thanks a lot.